So first I want to know whose favorite programming language is F-sharp? Right, well, how about who knows F-sharp? Okay. Who knows R? Who knows R but does not know F-sharp? Anyone? Okay. So there are no R experts. The reason I ask is because I'm not really an R expert, so I was hoping to be someone here to answer the difficult R questions. We'll see if we can win it. So first of all, I used to work for investment banks, so I used to have pages of disclaimers. This is my disclaimer tonight. I now work for a hedge fund, BlueMountain, and we have been building this R provider for, I guess, the last month. 2 months, I guess, since I started working there. We open source because we want people throughout the F-sharp and our community to benefit from it and hopefully improve it. So if you find you have any use for it, please don't just use it, please improve it. So this is what I'm going to run through. A bit of a comparison of F-sharp and R. What are type providers, because they're a new feature in F-sharp, so presumably not everyone knows what they are and what they can do. We're going to talk about the R type provider, talk about some of the challenges in producing this, and the growing pains in the type provider infrastructure in Visual Studio, because it's new and it's not perfect yet. And then talk about whether it's worth to do this thing. So here's a lot of stuff on F-sharp and R. So F-sharp is mostly functional and I guess equally with a sort of more of a weighting on the functional. It's kind of, I think of it as being the two kind of side by side, not particularly tightly fused. If you think about something like Scala, it's more OO fused together with functional. So I kind of think of F-sharp as functional plus OO. R is kind of a little bit of a strange language, so it's got some functional bits, and I'll show you some of those. And it's got a crazy object-oriented system, which was clearly bolted on afterwards, rather than being part of the design. You'll see a bit of that as well. So other things, compiled, F-sharp is compiled, though it has an interactive window that compiles on the fly for you. R is interpreted, and it's really interpreted, so it kind of has data structures that represent what you're going to be evaluating, and they get kind of reduced by the interpreter step by step as it goes. So it's really, really interpreted and not fast. But it's still a useful language. F-sharp is statically typed, R is dynamically typed, so you know that. F-sharp is, let's say, okay for exploratory analysis. So when I say exploratory analysis, I mean being in an environment where I can explore some data and some APIs potentially, and figure out what I'm doing on the fly rather than having a spec of what I'm trying to code up. Right? So F-sharp is okay because it has an interactive environment. It's quite flexible, allows you to change code very easily. But it doesn't have great tools for the interactive environment isn't fantastic, and by some standards. It doesn't have great tools for visualization built in, etc. So it's okay. R is very strong for exploratory analysis for readers. But for building systems, F-sharp is, like most .NET languages, is a great platform for building systems. Any kind of application or system you're building, you can build something, you compile it, it will be statically checked. It will be robust, you change things, you've got a good chance you're not going to broken anything. That kind of goes with static typing, right? Whereas R is completely unsuitable for building systems because you have to run inside the R environment, you can't really kind of compile it. The thing where R is really strong is stats libraries, right? and also the visualization tools. So R it's not particularly designed for statistics, but it's considered to be a statistical environment because people have built packages in the stats space that for R over a long period of time. And so it's really like the best place you can go to get stats functionality. And at a hedge fund, typically you want to do econometric analysis, so you do all the stats stuff. F-sharp is fairly weak in that regard. I think the .NET in general, math libraries kind of are okay. Stat stats are okay, maybe, but nothing compared to R. Python is sort of in the middle, further towards R. It's got sort of stronger libraries. Visualization tools, again, basic in F#. They tend to be prettier, the .NET-based ones, but R's visualization capabilities are very powerful. Data acquisition. R is not fantastic for data acquisition. F# you get a lot of links to different database providers and data sources, but for .NET you can use those in F#, so it's a good environment for data acquisition and processing. R is pretty decent for processing as well. And F# is scalable in many ways, so it's quite easy if you want to write multi-threaded code. It runs very fast in the first place because it's compiled, but you can make things scale up to good speeds, handle good volumes. R is not really built for scalability, it's built for kind of more ad hoc analysis. So I think from BlueMountain's perspective, this is really kind of these things to do with building systems and stats and maths and exploratory analysis, and why we kind of are interested in fusing these things together, right? We want to get the best of this list and the best from this list. So that's kind of why this is an interesting project for us. So since some of you know R, but not all of you, I'm going to give you a quick demo of R. And like I say, I'm not an expert, so don't expect any really in-depth stuff, but let's see if we can get R up here. Okay. So I'm using an environment called RStudio. There's a basic, so R is, like I say, it's interpreted. There's a basic REPL, there's a command line REPL. There's also this R console, which is just a textual REPL in a window. RStudio is an open source project that contains a REPL and editor window. It's kind of an IDE, but not to the extent that Visual Studio or Eclipse is. And you can sort of see plots and things like that, and you can explore the help and the packages that you have on your system. So it's quite a nice environment for working with R. Okay, so I'll show you a few things in the REPL that you can do with R. So the first thing is arithmetic. We can add 1 and 2, and we get 3. The reason you get a little 1 on the left-hand side there is, I guess, a little bit interesting that I didn't mention on the original slide. So R is a vector language. So most data structures are vectors. So there is no scalar integer type or scalar numeric double type. Everything is a vector. So this is a vector of length 1. So that's why the 1 does not indicate the length, it's just kind of the index of what it's showing. So a lot of what R is good at is based around that vector capabilities. We can do assignment, x equals 3, and then we look at x equals 3. There's 2 syntaxes for assignment. That's the R1, and that's basically equivalent. I believe just as statistics. So the next thing is vectors. So like actual vectors. So if we do this, C123, what we've got is actually a numeric vector of length 3. So by the way, you see one thing we have in RStudio is you have a browser for your variable binding. So we can see here that x is, I just clicked on this, a vector 1, 2, 3, and x is 3. The thing that says fix here, I just clicked on. So, like I said, everything's a vector. So if I look at type of is one way you can find out what something is. So type of x is double. Type of x also is double. It's all the same. And so you can do vector operations. So if I do x is plus x, so here I'm adding a vector and a scalar, which in F# you would not be able to do usually. So here what it's done is it's added the scalar to each of the elements of the vector. And so what R does is actually repeats the one vector typically until it fills the necessary space. Other interesting things, so we do x is greater than 1. So this x is, as I say, vector 1, 2, 3. So that gives us back a vector of booleans, or logical is done in R, which indicates which elements are greater than 1. So that's it's kind of interesting. And if you're dealing with a lot of vector stuff, it can be very useful to work like that. So I said that R was somewhat functional. One way that I think is quite functional is that functions are values. So the syntax for declaring a function is like this. And I can do multiple lines, braces. So now, so the reason I say this functions of values is I'm actually assigning the value f, or assigning the identifier f to the value of this function. Right? And it's valid to just say, take the f away, and then I just have a function. Right? So it's very much like in F-sharp, let f equal fun x arrow x plus 1. So it already has a concept of higher order functions. One really, I think, a really interesting thing about R is you may have wondered why it gave me this whole text here. This is a little bit odd. So everything, like I said, everything is really interpretive. So the value f is actually a data structure that describes the function's signature and all of the source code for that function. So if you look at a function and it's one written in R, not one in the underlying C libraries, of which there are many, then you'll actually see the source code for it when you type the name of the function. So that can be quite interesting, quite neat. I quite like that aspect. What else do I look at? So let's look at more complicated functions. C. Well, actually, it's not that. So C was the thing that creates a vector. So you can see here when you look at this is kind of interesting. So just start with on the right-hand side, we've got dot primitive C. This is how you kind of call into a primitive function in a runtime. And you can write your own things in C as well. This shows some of the details of our arguments. So dot is a var args, a parameter array in the .NET world. So that just means you pass any number of arguments. That's how I was able to write 1, 2, 3. Recursive equals false is an optional named argument. So I'll only be passing a value there if I say recursive equals in my argument list. So, and I believe that kind of traverses down nested vectors as well, in case you're wondering. So there's some kind of interesting things there. Let's do something more funky. So the main data structure that people use for data manipulation in R is the data frame. It's data frame and time series objects. So it's the main thing people work with. So I'll show you a data frame. So we can do df equals data.frame. Okay, so what I've done here is I've created a data frame, and I'm saying I'm passing two vectors. Okay, I'm saying A equals and B equals. So A and B are just arbitrary names I've given to those vectors. When I look at this data frame, so it's now in tabular format, and it's got these values A and B. So an interesting thing here is that I can pass named arguments. They don't have to be names that match up with the formal arguments of the function, which is different from C# and F# functions, right? So if you pass named arguments in C# or F#, the names have to match up with the names where the function is declared. Here I would just give arbitrary names to my functions, to my arguments. They go into the ... and the receiving code can use that information in useful ways, like labeling the columns. Yes?
So how come it says that df is 3 objects of 2 variables?
Okay.
3 rows of 2 columns. Yeah. A and B are.
So an object is not A and B are
three
not
observations of 2 variables, right? So it's viewing.
Oh, 3 observations.
It's viewing the variables being A and B, and then there's B observations. Yes, that's one interpretation. So actually, one interesting about data frame, which it probably looks like some elaborate class, but actually it's not. I mean, it kind of is, but it isn't. This shows you something about the crazy OO system in R. So if I do class of df, it says data.frame. Okay, and if I do type of df, it says list. So what this means is a data frame is just a list, right? And the list is basically a list of vectors. And when you create a data frame, essentially what it does is decorate that list with an attribute. So R has, you can assign attributes to any value, and that attribute, there's a special attribute which is class, and it's set that value to be data frame. So if I look at the data frame, it looks like that. If I do unclass data frame, that actually takes away the class from the data frame. So now you can actually see its representation. So the representation is in values in R is typically just one of the built-in data types, and then it's got this class attribute attached to it. So this is how list values are displayed when we print them. So $A is the name of this entry in the list. This is the vector 123, $B 123, and then we've got these row names, which are you can also name the rows in the data frame. So they default to be ordinary index. Does that make sense? What happened there, kind of? So we've taken away the classness because all it was just a bit of an attribute of decorating that list. And most of the classes are like that now. One interesting thing here is when I print df, so that's just the same as outputting, right? So print, when we output in the console, it's just called the print function. So the print function is essentially a method, but R doesn't use dot notation to dispatch methods. So we just have generic functions. So print is what is called a generic function, which is basically a method, right? So it says it's a function x, so it's a function of x and some arbitrary other arguments, which modify how the thing is printed. And you use the method print in order to implement this. So what does that mean? So what that actually means is there's a function called print dot data dot frame, and this is actually the code it dispatches to if you print a data frame. So there are actually two object systems in R. I told you it's a bit crazy, S3 and S4. S3 dispatches using this funky mechanism where it takes the function you called, and if it contains use method, it's got a string, print in this case. It then looks for a function called print dot and then a class name from the class attribute of your value. It's kind of not a particularly formal class system. And you can attach multiple classes to a value as well, and then it will potentially traverse the list and find an implementation. I can actually modify the data frame. I can take away the class attribute and set it to nothing, and then it's no longer a data frame. It's just kind of the underlying representation. So there's not a lot of encapsulation here, but it's quite a flexible system. You can do a lot of useful things. So that's a little bit of R. I'm not going to show you this. There's a lot of stuff in the sort of graphics component space. I'm not going to show you that in RStudio because I'm going to show it from F-sharp. It's kind of pointless. But anyway, obviously the whole point is there's a lot of functionality here. I haven't really showed you any of it, but you can see like the built-in packages here. There's a whole bunch of stuff. We want to be able to use that from F-sharp. We don't want to pick up necessarily these sort of crazy semantics of everything, but we want to be able to access the underlying libraries. That's really what we're going for here, is accessing the underlying libraries that are really useful for the stats. Okay. What's that?
What's invisible?
Well, I don't know. I think what it means is that it doesn't print out X, but we can do help invisible. Return a temporary invisible copy of an object. Does that answer your question?
Absolutely.
My guess, and this is so I think the idea is it's returning a value, it's returning X, but it doesn't want the REPL to go and print X. Yeah. So if I do print, so when we do this, print is the function we're dispatching to. Print is going to return the data frame, yeah. But then, if it did, then R would also go and print it again, yeah. So I can now say if df2 equals print df, and now df2 has been assigned to that return value of print, but it didn't print it out as a result of auto print. Never used it before. But there you go. All right, back to any more questions before I. That's your intro to R, so if you're hoping for more, sorry. Okay, so I just kind of touched on this, but why do we want to mix them? What was their motivation? So We at BlueMountain have a lot of functionality in .NET libraries we've written in C-sharp over the years. And when we set out on this project to build this exploratory data analysis platform, we wanted to be able to leverage that functionality rather than going using R or Python or whatever. We wanted to be able to use the data acquisition and transformation in F# and .NET because we think it's quite powerful. We have access to a lot of different data sources there. But we wanted to be able to use the stats, graphics, functionality, and modeling functionality from the R libraries. And we wanted to be able to build this stuff into robust systems. So we couldn't have had sort of R processes sitting around being spooled off and running scripts and things that feel like would be robust. So what we do in the R provider is, I was showing you the R record, right, which is a standalone process. We call down into the RDLL, which contains the core of the R functionality. So it all runs in your process. It's pretty lightweight in terms of what it actually does. And you can basically just kind of through a few layers and some not inexpensive transformation. You're calling into the functionality of those libraries. There's a number of ways you can call into R. So initially we're using RCOM. Now RCOM is actually a cross-process access to an R session via DCOM. So when we didn't have very much functionality available, that was useful because we could do some stuff in R, in F#, and then essentially split the values across to R, and then go and play around with them in R, and then potentially pull some values back. We still like to be able to do that, but that's not kind of the primary thing we want to do. It doesn't help us build robust systems. The other thing is that RCOM is a commercial product, it's not open source, and we wanted this to be an open source thing, so that wasn't really a good approach for the R provider. So another thing you can use is RServe. That provides a client server, software server access to an R session. So that's useful for, there are various things that have kind of a web-based UI, and then they talk to an R session over this socket, or they may have any kind of remote, basically. So that wasn't what we were looking for, but that's something that might be useful in some cases. So we decided to we could have used RDLL directly via key invoke, but a guy in Japan named Kosi had written a thing called R.NET, which provides .NET wrappers around RDLL. So he has classes that represent all of the concepts, pretty much all of the concepts in the RDLL that are described in the C headers, which are fairly complicated. The main data structure is a thing called a symbolic expression, which is a thing that represents a value in R, and it's kind of a variant type that represents different kinds of symbolic expressions. So there's some pretty nice object-oriented wrappers around that stuff. So we built the R provider on top of that. We actually exposed results using that type as well. Okay, so what are type providers? Has anyone not seen a type provider talk? Anyone have no idea what a type provider is?
I tried to read the documentation. It confused me. I stopped. I thought you'd tell us.
It confused you?
Well, I didn't read it very carefully because I figured you would teach us.
Okay, so a type provider is, I think, really, the idea is to make data really easily available inside F# in a strongly typed manner. And it's to kind of address one issue that drives people to dynamic languages, which is that you can easily put in data and just access data as if it was, you can do like data structures dot price. Even if you haven't written any type declaration that says there's anything called price in there, because you just dispatches it at runtime. The point of type providers is really to dynamically inject type information into the compiler and IDE, where that information is derived from static parameters, which are things you specify in your code, which is usually strings. There'll be things like a database connection string or a web URL or something, and potentially access to an external resource. So if I give you a URL that returns, say, a JSON document, then the type provider will, while running inside the IDE or compiler, we're going to take that static parameter, which is the URL, we'll go and access the external resource, get back the results, and infer the schema of the data you're accessing from that. And it will then expose in your environment strong types that describe that object. Does that make some sense?
Mm-hmm.
Okay. So it's kind of a way of typing things that are traditionally quite hard to type in static type languages, unless you do it manually. Potentially you can perform operations. You can basically, when you provide types, you can generate a whole bunch of operations, methods on those types, properties, etc., that might perform manipulations of that data in ways that are not necessarily easy to statically type, because you just kind of generate the underlying data. So it's fairly unexplored as a way of working at the moment, but it's being used for sort of basic stuff. So the typical examples you'll see in the talks are things like SQL database, for obvious reasons. So you can do that by code generation, right? We've got SQL Metal and things like that come in Visual Studio and generate mappers, so things are strongly typed. But the F-sharp data provider will do that dynamically. You can give it a database string, connection string, you give it a query, and then it will go and dynamically generate the bits of strong static types that it needs to perform your query. And you can write the query using the static type information on the underlying tables using link style queries. F-sharp as well as another thing they added in F-sharp 3 was roughly the same level of link support that you get in C#. But that combines really nicely with the type provider mechanism, so that you get the static type information dynamically in the first place. XML, same thing, so you can access an XML file. Someone wrote a regular expression provider, so that doesn't access an external result. You give it a static parameter, which is a regular expression, and then any named parts that you abstract from the regular expression, it then makes available as properties on that. So that's kind of cool. You can imagine doing things like printf, statically typed using that. There's some debate provider that does that in F#. What else is there? OData, like Netflix, exposes OData as web-based mechanism to describe data. Freebase is another one. Someone wrote a file system provider, so you can just do C dots, and then you see all the contents of your file system, program files, docs. Kind of that's not necessarily robust, just like hard coding parts, but it can be useful for kind of putting in data. So it's quite a flexible method. What else? So downstream code is statically typed. That's really an important thing. Putting in the data essentially is not statically typed because you're just deriving the schema from the data. Okay? So you're then saying, I expect the schema of that data to continue to be the same as it was when I wrote my code and imported that schema, which is usually fine. The same thing will be true if you write dynamically typed code that you're accessing members, fields. Those fields need to exist when you access it. And the main thing is you get a really good IntelliSense experience. I'm not going to really demo this in the context of data, but you can explore a database and everything will just appear with press dot or something. It will just appear. All the fields will appear. They'll all have the right types, etc. So that's kind of pretty cool. The demos that the F# team do use Freebase, which is an open database on the web that has thousands of different entities. You can query and kind of explore this space very dynamic. So it's nice. And basically the way type providers work is lazily, depending on what part of that space of types you actually use, it discovers what those types are, and then they get generated at compile time or IDE. IDE is essentially invoking things in the compiler and injected into your code. So what ends up in your code when you use a type provider is, roughly speaking, what you would write if you were writing dynamically typed stuff. You're going to get this thing that's called thread from the data. So the schema essentially gets baked into the code. You don't need any other bits. That depends how you write the type provider. That's Alright, so does that kind of make sense? Does this become a little bit clearer as we move on? So I mentioned you can do this stuff with code generation, right? So SQL Metal, Visual Studio, and there are other tools I'm not that familiar with that will go query a database, get a schema, and generate a whole bunch of static types. So generally, most of what you can do with type providers, you can do with code generation, and people have done for years. The only reasons not to do that are some of the problems don't scale well with code generation. So Freebase, for example, that has thousands of different schemas for different entities, and so you can't code generate all of that stuff. It would take far too long and be far too big. So the fact that this does it lazily only for the area that you're exploring is very useful. And also this is, process-wise, as developers work with this stuff and the schemas change, etc., and new stuff gets added to your data sources, the process of the code generator is a bit of a hassle. You've got to know when you've got to regenerate the code, right? What I'm trying to do isn't working, this thing doesn't exist, I need to go regenerate my code gen stuff. And then you have to know what the code generator is, which you probably don't know because most of the time you don't have to do this, and you don't have to regenerate. You have to know how to invoke it, what its arguments are, potentially. It can be a pain. So code generators tend to be kind of non-uniform in the way you work with them. So one thing nice about type providers is kind of a uniform mechanism, right? So they will take different type parameters, so static parameters, but those will be discoverable in the IDE just like other parameters. And they'll be kind of coded up into your code ready for them each time you regenerate. There are some downsides to this that I'll talk about later, but those are some of the upsides. I'm in the cell mode at the moment. At the end, I'm going to get to the caveats. So I think it's actually somewhat, having done both for R, it's somewhat simpler and less error-prone to write a type provider than it is to write code generation. Which might be surprising, you might think it's quite complicated. The reason is that there are good mechanisms in the infrastructure for writing type providers for you to generate the code. You use F-sharp quotations, so you just write kind of regular code in your type provider and you quote it, and then that gets injected into the calling assembly. When you write when you do a code generator, unless you've got some, we typically don't have good mechanisms in C#, F# for generating that code, though Roslyn there, getting better for C# anyway. But generating code using strings and things like that is pretty error prone. So I found it easier doing the type provider code gen stuff. Alright, the R type provider. So, as well as accessing data, one thing that I realized when type providers were announced, I believe Microsoft experimented with, is that type providers can be used for interlanguage interop or metaprogramming. So you can expose the API space of some other language or environment in F# using a type provider. And I believe Microsoft have experimented with writing a COM type provider, right? So you can access COM stuff. I believe they've also experimented with writing a WinRT type provider. So in F# in HTML, doesn't support WinRT directly. It supports the .NET stuff. So I believe you could do something more direct if you really want to. So that's kind of interesting. It's an interesting alternative application for type providers. So the external resource in my case, the schema, is the R environment, the packages you have, all the functions that exist in those packages. Those are the things I'm reflecting over in order to provide types. And the basic objective is find out what R packages you have available in your system and make them available as .NET namespaces. So I can go and open that .NET namespace and just call it as if it was a .NET function. And values as well, they're not all functions. It's basically the same thing. So like I mentioned, it uses R.NET. It's pretty lightweight in process. And one thing that I was keen to do was everything, when you call a function in R, all the results are kept in the R environment, in the R representation of the functions, unless they're explicitly converted back to .NET. Right? So it's all in process anyway, so it's not that expensive. But you can call a series of R functions and keep all the data in R's representation and symbolic expressions, so you use a large data structure to call something else with that. And if you want, you can kind of explicitly save an object, so R has the ability to save any arbitrary object in a file. You can go to a real R session and open up that object if you want to use a real session. And this is where you can get it. So on GitHub, so you have to have to F# R provider. So you can download there. I generally recommend downloading the source to be kind of still maintaining it, don't necessarily binary address. But if you want to use it, grab it and please log issues or make suggestions or make improvements. Okay. I'm going to demo it in a minute, but first I wanted to talk about some of the interesting challenges of doing it. So I mentioned at the beginning that R is dynamically typed, and F# is obviously statically typed. So how do you bridge that, right? If you try to get the benefits of working F#, you want to have some static type. I mean, you can't really because it's dynamically typed, right? And in R, there's some interesting properties like Yeah, obviously you can't discover the type of an argument by looking at the formal arguments of the function, because it doesn't have a type assigned to the type. But actually all arguments are optional. Although they can have default values, you can also call the function not supplying an argument, a value for an argument that doesn't have a default value. So basically every argument is optional. It has kind of the var stuff that we saw earlier, the ... right? So we have to kind of map that on. So this is not trivial. And the way I kind of looked at this, and the way that I somewhat uncharitably look at dynamically typed languages, is that if we're talking about static type, compile time typing, right? So dynamic languages basically just have one type. Right? That is that type at compile time if there is one, or the kind of static analysis time if you're in an IDE. Everything is of the same type, right? So you can call that any or object, right? So they basically just have one type. And .NET-based statically typed languages like F#, C#, they still have a dynamic type system of runtime that you can use, right? Quite a rich one. So we can do dynamic dispatch even if we don't have static type. And one thing that makes dynamic languages much easier to use than, say, C# or certainly F#, if you're just using one type, is that they have nice lightweight syntax with various kinds of dynamic operations like dynamic dispatch. So that's my way of looking at static versus dynamic typing in kind of original. Well, yeah, dynamic typing, you just have one type, so we're just going to use one type, which is object, because that gets a value of any type. And then we're going to figure out, based on what the caller passes, what to do at runtime, which is exactly what a dynamic type language is. One thing that makes that easier is that R itself doesn't really have members in the sense you do object.member, right? So we don't have to try and mirror that, right? So we just use the generic function idea like we saw with print, right? So if we have a function called print, we're just going to have that function, and depending on what you pass to it, we just get R to dispatch to the right type. So I mentioned earlier symbolic expression. So the inputs are all of type object, results are of type symbolic expression, because that represents the result. It's known to be inside the R engine. I can then pass one of these symbolic expressions back in as an argument, because it applies with the object, as everything does. This then becomes very flexible. You can do exactly what you want. It doesn't give you much help in the IDE. But it does tell you what the arguments are, the name of the arguments. It gives you IntelliSense and stuff like that. So we're going to do a demo. I've got some more slides, but we'll go back to those in a second. Okay. So we're going to go to Visual Studio. So I'm using VS 2012, which you need to do if you're using type providers. I've got a empty file, nearly empty file that does a couple of things. So I'm opening setup life for a second. So all that's contained in there is a function I'm going to show you in a minute, and also something that launches this F# interactive visualizer, which we've built, which is I find very useful because it actually shows you the values you're working with. You'll see that in a minute. And then here we're doing OpenR provider. So that's the R provider. And then I'm doing openrprovider.base.graphics.stat. So if you want to open a package here, we just do rprovider dot. Okay, so when you do that, so this is dynamically gone into R, it's discovered all the packages installed in my system, and then it's making them available in IntelliSense. So that's kind of how you access the packages. And so they pretend to be .NET namespaces. You can, R type providers, F# type providers can dynamically generate namespaces, not just types. You'll see here this funny thing here, base. So one thing, when you try and interrupt between languages or even database schemas, you'll find values or field names or whatever that are identifiers basically that clash with identifiers in your host language. And in this case, base is one of them. Although it's not, I believe it's not actually used in F# as a keyword at this point, right?
No, it is a keyword.
Oh, it is? Yeah. I think it's a reserved, so it's a reserved word. It's not, you don't actually use it, but it's reserved. So it's maybe I'm wrong. It doesn't really matter. Anyway, it's a reserved word. So you can't use it. So what happens, and the nice thing about this, so this tick-tick notation is a little bit ugly, but if I type base here, it quotes it for me, so I don't need to do it myself. So that's and it does that no matter where you are in the space. If you discover a function or a name that is an identifier or contains characters that are not allowed in an identifier in F#, like punctuation characters and things like that, and then you can just quote them like that. So that's kind of cool. C# does not have well, it has an @ symbol which allows you to use identifiers, but it doesn't have any way of you using characters that are invalid in C# identifiers. So it's kind of slightly different. Okay, so now what this does when you open as namespaces, this is kind of weird, but it works out quite well. So if I do r dot, then what I get here is the union of all functions inside those namespaces that are exposed under a type called R. So these are all exposed as static methods on a type called R, and there's a different type called R in base, graphics, stats, and zoom. The reason I did it that way is that I wanted to expose them as namespaces. I thought it was a nice way of doing it. But you can't actually expose module level functions in type providers. So it doesn't reflect the F# type system. It only reflects the .NET type system. And in the .NET type system, you basically can't have top level functions. They have to be members of classes. So this is basically a bunch of static classes containing static members. And one nice feature of F# is that if you open the multiple namespaces that each have a class called R, then or anything, then you call R dot, and it will actually give you the union of those. So that makes it work quite nicely. Right. So like I said, the type providers at this point, they only reflect the .NET type system. They don't reflect the F# type system. So there's no modules, hence there's no auto-open modules. If you try generating the same thing as the F# compiler does, it doesn't work. It does not recognize them. So it's unfortunate, but given their version 1 support was intended to kind of let you do really kind of data access, it wasn't that important. And for other reasons, I use optional arguments, overloading, named arguments, parameter arrays, all of those things are only supported on member functions. They're not supported, all of those things are not, none of those things are supported on module functions. So I couldn't have used module functions even if I wanted to. All right, so let's do some stuff. So I'm going to get some data. Now, the code we have at BlueMountain for using this is using an internal data source, which I can't use here, but I've got a function called get_stock_prices, which is the same thing we use in the online demo of this. This is a function that goes to Yahoo and downloads a stock price CSV. So if I want to put in Microsoft stock prices, I do this. So this is not using any R yet, but this is now pulled in. So it's pulled in Microsoft stock prices, and you can see here this is a visualizer. So you can see here this is a array of observations. The observations have these date, open, high, low, close, volume. So this is the data we've pulled in. Goes back.
So get stock prices returns an R type? Something?
No, this is not R yet. This is all F#.
Okay.
So this is kind of in the spirit of doing data analysis, data acquisition and manipulation in F#, and then using R for the stats and graphics capabilities. So it's all F# so far, or .NET, F#, whatever, same thing. Okay, so we've got that. We can see it. So let's do something R with it. So this is time series data. So one thing we can do is use kind of. I haven't got a lot of time to do anything elaborate, but let's do something simple. So if I use, there's a function in R called, or there's a package called zoo, which is for time series analysis. So this is where we can actually see the function. So you'll see that if I call zoo, I've got two overloads The second one is actually the more obvious one. This, unfortunately, I can't make that any bigger. So this says zoo takes X obj, order by obj equals obj. So, and all of these are optional, though it doesn't indicate it here. So this is the natural type of that function. And so X, I can give it anything. Order by, I can give it anything. And frequency, I can give it anything. I won't give them nothing at all, but I'll get a runtime now. So you get some information. It tells you get back the symbolic expression. So I happen to know that X is the values, the observations, and the order by is the kind of index, so that would be a kind of date. So if I want to construct one of these things.
What's the type of the MSFT right now? Is it the also type provided from your CSV file, or is
no,
it?
it's not. I'm not using a type. I would normally, but I'm not in this case.
What is it?
It's this type array of observation, which is an F-sharp reference. So it looks the same as if it had come from a type provider. I just didn't use a type provider. I should have, but I didn't. So if I do something like, I'm going to extract the closing prices. So that's create an array of the closing prices. And I'm going to take for the order by, I'm going to take the date. And then if we're lucky. So that has created, that's called the R thing, and we see a couple of things. So it's called the RZ function. We see a couple of things. One is in this console window here, which is wrapped a little bit, we'll see some output from R. Loading required package zoo, and like giving them some warnings that would happen if we did the same thing in R. And then this result here is what happens if you take that time series object in R and you print it. Okay, so that's what you get in R when the source is coming up. So I set up a printer in F-sharp Interactive that will print it out using the R print function. So you get the R representation of it, which is quite useful. On the right-hand side here in my visualizer, I've got, so symbolic expressions are not particularly well visualized at the moment. It's just converted to an array of the values. It doesn't have anything. So this is the way this visualizer works. You can expand and contract the things whenever you evaluate anything. Okay, so that's zoo. Well, I can do something with that. So I can do r.plot z, and then we get a plot from R. So this is R has spawned this window. I'd like to be able to embed these in .NET applications, but it doesn't work yet. So this is the time series of the prices of Yahoo from Microsoft that we got from Yahoo. So I don't have time to do anything more elaborate. And I'm not, also, as I said, not an expert in R, so I'm not able to do anything more elaborate, particularly with time series. But this stuff is used quite heavily by people who are good at R. Next thing I want to do is use some data frame stuff. So what I'm going to do is I'm going to get I'm going to try to compare the returns, the daily returns of various stocks. So the way I'm going to do this is, so let's start by saying I'm going to get Microsoft. I'm going to make this work, and then I'm going to turn this into a function after I can actually check that it works. Okay, so if we have a identifiable stock, we do that, so we already know that works. So then kind of showing you okay, we want to get the closing prices, like close. So what I'm going to do is only if the, I don't want to deal with quite so much data, so only if the observation date is after today minus 365, so after a year ago. Only if it's within the last year, and am I going to yield close. Okay. That just means I'm working with a little bit less data, so now I've done this correctly. close will just be an array of doubles, which is the last year's closing prices. And then what I want to do to get daily returns is I want to do, this is a way you can use some R functions. So we can take the log of a whole vector using r.log, which is quite nice. So so that's the log of that whole vector. And then we can do diff. That kind of does a difference between lagged values. So this is going to give us the daily returns. So that's that. And so because these are vector operations, I do it on the whole vector at the same time. Then. So, okay, so that's going to give me returns for something called stock. I'm going to make that into a function. Stop me if you're not following. So make that into a function. Okay, so now we should be able to do, if I want to do like r.pop get returns for Google. Thank you. I have not so to send that to So now we get, these are the returns to Google. So these are daily returns, right? So they hover around 0 and they go up and down. Okay, so we do that. So now we're going to get for a bunch of stocks. So let's do. I'm going to do something actually. So for ticker in. Let's do Microsoft. Do what? No. I don't want to. I don't know it well enough.
Is it possible to get the numbers back into F#?
Yeah. Yeah. So yeah, I'll show you that. Sorry. So what have we got? So, well, I mean, you can actually. Okay. So let's do. This. Okay. So this is printing out the results of using R. But if I'm going to get it back into F#, I can do returns dot value. This is how we marshal back, right? So the type of returns dot value is just a double array. So what happens here is, well, the type of returns dot value is object, but it kind of dynamically, you can see this is value object, it happens to be a double array. So based on the type of the symbolic expression, when you call dot value, or when you access dot value property, it will give you back an appropriate thing.
Sorry, and then you have to downcast it over.
Yes, what you can do, if you don't want to use a property, or if you want to get it statically typed, you can do returns dot get value, and you can assert that you want this to be of type double array. And then gives you back the same thing, but the static type of it is double array.
Except, of course, if you were to call it and it were to give you back something that it couldn't coerce, that you still hit the runtime error.
Yeah.
Okay.
So you're asserting that it's not statically checked. So if I did string, right, it will say no converter registered to convert from R numeric vector to type system string array. So the way this works is a bunch of built-in converters, which kind of deal with the basic built-in types. But because we actually have our own our own proprietary types, we have a plugin mechanism using MEF, the Managed Extensibility Framework. So you've got your own data types that you want to convert to, or say you wanted to convert to some cloud numerics data vector or something like that. You could register a plugin which is discovered via MEF, and then when you call get value passing that type, it will look for plugins that do that conversion. So it's kind of, that was how we made it kind of open source, core, but extensible to proprietary things as well. So it's, I quite like that aspect of it. So I'm going to do here, what was I doing? Did that answer your question, Richard?
Yes, definitely. Thank you.
So I'm using a bunch of tickers here, so Microsoft, Apple, Google, X, which is some kind of
Steel.
steel company, right? I can't remember which one. The XX, which is, I think, small next maybe. And gold. Okay, so we're getting those, and then we're going to return ticker, get returns. My wife is obviously like updating our SmugMug page because I'm getting all these like Dropbox updates there. Get returns ticker. Okay, this is basically for each of these tickers. For each of these tickers, we're going to return ticker and get returns. I don't think personally the query syntax would be nicer. I think the more complex stuff. Okay, so if we're lucky, and I've done that correctly, then we're going to get back so data is, well, let's have a look here. So data is an F-sharp list, suitable string, and a symbolic expression. So it's a symbolic expression because we did that inside get returns, we did that r.if r.com. So we don't actually see it, let's visualize it here. We've got each of those things. So this is kind of a hybrid .NET R thing. So each of the vectors is living in R, and we've got kind of a handle to them, which is inside this list. But that's fine. We can deal with that. No problem. Okay, so now we've got that. We can create a data frame. So a data frame is basically, the thing that we saw in R, right? So it's got a bunch of vectors, their name, and a whole bunch of analysis you can do with data frame functionality, so it's kind of useful to have. And we at BlueMountain, we have our own data frame in .NET, so we have converted to and from the data frame in R and our own data frame that we've registered plugins to do conversion, so kind of pass between the two worlds quite transparently. So, now, this is where it gets tricky. Because as I mentioned when we constructed the data frame, we supplied names, and we remember in RStudio, let's get rid of this. We supplied names when we constructed the data frame, right? Wherever it went. Okay, A and B. And those are named arguments essentially. I'm passing those names, but they're not formal names of arguments to the data frame function. It just takes dot. So dot is like a var, it's like a parameter in .NET, but parameter in .NET doesn't let you associate names with those values, so that makes it a little bit more tricky. So the way I kind of bridged that in the article, there's actually a couple of ways of doing this, but one way was that you may have noticed that every function actually has two overloads. One takes like the individual arguments. The other one takes a dictionary of string to object, which contains the values. You can also pass pairs, .NET pairs, as the var. So if you .NET tuples. So if you want to just pass things you know the names of, you just pass the tuples. So that works really well. So I'm going to use this one in this case. So the way that we do this, I've got a little helper function called named params, and that basically all it does is kind of deal with the covariance here. So named params will convert this into a iDictionary of string to obj, whereas it's actually an iDictionary of string to symbolic. And then we can just pass that into here. Now, no doubt that will be slightly confusing what's actually going on there, but you'll have to kind of trust me and look at it a little bit more if you actually use that. So we do data, we get that thing. We do r.data frame, we get a data frame. Let's do let df equals. Then we get this data frame. If we look at that, so I don't have a visualizer, right, for an R data frame here, so it doesn't look very sensible. But with our in-house stuff, we convert that back to a .NET data frame to show it. But we can do kind of interesting things with that. So we can do, like we did before, we can do type, which is equivalent to the R type of, and we can see that this is a type list, which is just what it was in R. So we're actually going and querying the R data structure. We also, I didn't really show you, I did show you class, right? So we can also do our df.class, and we can see that that is, the class is data frame. You can see that's an array, because class, as I mentioned, an object can have multiple classes, so that's actually an array. So this is constructed of a real data frame. So that means I can call a function like my favorite pairs function. Pairs function takes a, can take a data frame, and then it does a pair plot between the columns in that data frame. So this is where we're starting to get some of the nice plotting functionality in R. So this bit is not obvious. This is showing, when we've got this one here is the plot of Microsoft against Apple. That's the inverse, and this is Microsoft against X. So you can get an idea here of perhaps how correlated the returns are. So if we look at like this one, looks like there's a little bit of correlation between Microsoft and Apple and maybe these tech companies. If we look at DXX, and it looks anti-correlated, I guess, or correlated with a negative, not anti, but correlated with a negative slope there. Gold, looks basically like a splat, so that's that's uncorrelated, right? Which is typically, which is what people tend to say. So that's quite a nice visualization when you're looking at a bunch of different names. We can like pick a particular combination. So let's say we look at we can plot say Microsoft. Now I'm accessing my .NET type here, so rather than the R one, so it's kind of nice. It's nice to be able to mix and match them. So do this. But now this is basically zooming in on one of those in the Microsoft Apple one. So showing you the correlation data return. So if there's a dot here, what this means is on the given day that these observations relate to, what was the return of Microsoft compared to Apple. So we can do that. What else can we do? So we can also do, like I said, I'm not an expert in statistics, but it's not going to stop me doing a little bit of basic stuff. So we can build a linear model. So the linear model is basically doing a linear regression to basically essentially fit a line through that graph. Right? So just determining whether we can predict one from the other. So we do that with let's get this up here. R.ln is the so frequently used, has a very terse name. It takes a bunch of stuff here. So the main thing is the formula. So I'm going to say Microsoft fiddle Apple, which basically says Microsoft. I'm saying Microsoft's daily returns are linearly correlated with Apple. That's my hypothesis. And then I pass in the data frame. And if we do that. Okay. So you'll see what happened here was we've got a symbolic expression, which is saying basically it's fit aligned. The coefficients are, this is the intercept and this is the slope, which is true. So that's I believe there's a way of plotting that line on top of the graph. I'm going to have to do it, so I can't plan to do it right now. But we can also do one thing that R does. It's like give you can plot the linear model. Right? So if you do that, it shows you a bunch of stuff. So it shows you the residuals. The residuals are the differences between the predicted values given the linear model and the actual value. So if you're a statistician, you can make sense of these things and see whether you've got a good model. You can do part of summary, which shows you the coefficients, shows you the standard error. It shows you the values for a t-test to see whether there's a statistically significant relationship. We've got the r squared here, which is not particularly high, so it's not a particularly strong relationship. So if we do something that we saw as a comparison, we saw as uncorrelated, we would see a much lower R squared. So this is just touching the surface because, like I said, I'm not an expert. But basically, anything you've got in R, you can call here, and you can do all of the graphic stuff. So it's proved for us quite useful when we're doing kind of ad hoc analysis. We just pull in data, and we use our .NET libraries. We can call our finance functionality in .NET. We can call the R libraries to do statistical analysis, and it's really quite a powerful combination. So I've got a couple more slides. I haven't got much time, but
are the R packages generally freely available?
yeah, I think basically everything in R is open source. So if you want to download, if you want to download a new package, the way you do it is you have to go into well, actually, let's probably let's try something funky. R.store. I haven't got that. I don't know what that's in. There's a function called install packages. Let's do R.help. Let's see if this works. Do anything? Oh, I don't have help. How does that do? So we go off script. Details, R.help. Starting HTTP server. So we're down on an HTTP server running in F-sharp Interactive, serving up this help page. So install packages is in utils, so now I can do R.install. I think if you do this without any arguments, it pops in the GUI, and we can go and install something. So I don't know. You can see this is from CRAN, which is the central archive. There's a lot of stuff in there. So I don't know any of this stuff really, but we can pick a random one. Robust. That sounds like a good one. Who would not want something that's robust? So this now installs the package, downloads it. I've never done this before, by the way, not even once. So my guess is now that's now installed it, but my guess is that because I wrote this, I think this is not going to work because the set of packages is discovered up front and cached. So I'm guessing that we're not going to be able to do open R provider dot what was it again? Robust. Robust base, but not robust in this thing already. But yeah, you can install packages, and if you just restarted I guess you could get to restart the Visual Studio, and then it would get a cache. So I could. There's mechanisms recommended in type dividers. You can do like file system watches to see whether what you're looking at has changed. You can have other notification mechanisms. You can tell Visual Studio that you're invalidated your schema and it needs to reread it from you and stuff like that. So no, I haven't implemented it. That's possible. Okay. Running out of time. Any other questions? Okay, I've got a couple more slides. We use the right information. Alright, so I went over that. Some stuff about arguments here, default values, named optional arguments. We basically kind of covered that in using that stuff, but in named arguments you have to pass as a dictionary or as pairs if you want to pass them to RRs. Otherwise, you can use F-sharp's named argument passing where you say named equals. So that matches pretty well with F-sharp named and optional arguments. The only exceptions are the fact that in R, the parameter, the dot arguments will come before the named arguments, and often that's the way you'll want to use the function, because basically that's providing the actual data that you're supplying the function, and the other things that are named come after it kind of modify its behavior. So that's one thing that we don't deal very well with. We don't, because in .NET, parameter has to come at the end. Like we always talk about this, arguments can be passed using an identifying name or something. So that one you have to use addition. I think I've already gone over this argument conversion. So these are some of the basic things that are documented on the GitHub site. Construct lists by calling a function. Give your own classes. You can register a plugin, just discover the meth, just has to be the same directory. And then it has to decorate it with an export of a certain interface, and then you can basically do any kind of conversions you want. You can override the built-in conversions. You can, yes. Well, so we wanted to support implicit conversion of bespoke classes, right? But we didn't want to require people who wanted to write their own converters to fork the project and modify the code to support their own classes, right? If you want to modify the code to support some built-in .NET types that replace this conversion, that's great, right? Because you're just casting it for everyone. But if you're doing something where you're never going to be able to contribute it back to the main to the trunk, you don't want to kind of fork it because then it's more hassle to keep everything up to date. So that's why we do this via plugins, so that it's kind of slowly discovered. And that works quite nicely. I would show you. There's actually some stuff in as part of the framework that's written using these net plugins to do conversions, just because it's easier to do. You can use you can use the typewriter itself to write the plugin, so it makes it easier to write it in the core. I don't have time to show you that stuff. So I think I've covered all this. We talked about value property, we talked about get value. So this allows you, so value will always give you back the default representation of that type of symbolic expression. The obvious defaults are built in, and you can add or override it in the plugin. This guy, the get value function, this allow method. So you can specify the type you want. So this will allow you to do things like, you can say if you've got a numeric vector, right, there are no scalars, so you have a numeric vector of length 1, you can say I want it as a double, you'll get back to the double on the double array. It supports less as well as sequences, I need all strings. Yep, so that's arguments. Growing pains, alright. So having spent quite a bit of time and had my fairly picky co-workers playing with this, we've come across a few issues, and this is not just my type of provider, it's actually more the SQL type provider or other type providers. So the great thing about type providers is that you can load up a bit of logic into your compiler in your IDE and make it kind of customize what it's doing. But that's also the bad thing about type providers in some sense, because to start with, they're locked when they're loaded up, right? So if I'm constantly changing my type provider, it can be a bit of a pain because I have to restart Visual Studio all over the place. People have had to do that quite a bit. We've had some problems if type providers are dependent on other assemblies. We've had problems getting those resolved. I think those are bugs in the way that those type providers. I view the locking as a bug as well. I like to shadow copy these things because I want to be able to change them. And surprise, surprise, accessing slow external resources will slow down your IDE and your compiler. And if your thing, like if your network, if your database server is down and it takes 2 minutes to time out, your build something takes a long time and then it fails because your database server is down, which is not a failure mode we're used to as developers typically. So that can be a little annoying. Typically you have kind of schema caching mechanisms in type providers, but if you use them, then you kind of get around that. But it's unusual failure case. Buggy type providers will crash your IDE. The bit that's running in the IDE, that fails, crashes. So their recommendation is kind of run it out, process, do remoting and stuff like that, which I don't do. But obviously it can crash the compiler as well. But yeah, I don't write buggy code, so it's not a big deal. Yeah, so machine configuration, you try and build one of these things when you don't have R on your build machine, it's not going to work. Fortunately, R doesn't really need to be installed. You can actually kind of put it in your source repository at this point. You will have the same packages installed that you're using, right? Again, you can deal with. If you can put these external resources and source control along your source, and you put in schema files, then instead of the external resources, then you're better off with a more robust system. But these are kind of growing pains. Hopefully, these will be improved upon. Overall, was it worth it? So I think I'll confidently say that having this integrated access to R from fsharp Interactive is extremely powerful. It's really a great thing to have that. It's helped us a lot. However, this particular problem can be solved with code generation. Right? So we can code generate that we have. So we can use R and C# as well. We've code generated wrappers using the same kind of core stuff, importing into R. We built with R type provider, and then I'm going to release that as part of the open source project as well. So that, this isn't something that really requires a type provider. you can just code generate, check in your code generated stuff, and then just use it. However, the process is much more fluid, right? If you're doing using type provider, you can access any package you've got installed. You don't have to run any code generator with any parameters, and don't have to run it, know how to run it, etc., which is going to be an issue. On balance, the issues in the previous slide. I don't know really whether it was worth having a type provider in this case, but code generation is probably fine. One of the more interesting future applications of type providers are kind of intra-language metaprogramming. There's a bit of text on the intro to type providers on MSDN which says type providers are not intended for intra-language metaprogramming. So that must mean that this is an interesting application of type providers. So what that would mean is things like if you could invoke a type provider with a static parameter that was, say, type, and then it could perhaps manufacture other types. Or if you could use it, you could provide static parameters on methods and use type providers on exposed methods so that, given these static parameters and the types of your arguments, you could derive a different return value. You may be able to do things like type operations that we can't type at the moment, like relational joins and things like that, which are quite hard to type. People go to great lengths in languages that have strongly typed systems to try and type those things. The result is quite heinous, or at least in terms of understanding what the hell's going on. So this might make, if it was extended in this space, it might make it, might be quite nice. So overall, it was worth it. Just about like you have this particular problem, you could use code generation. Everything else is still the idea of integrating the two of them is still good. So that's it. Any more questions?
What license are you distributing this library?
This is a BSD license.
Okay, the reason I ask is R itself is GPL.
LG, yeah, GPL. Yeah.
It's GPL. So does that not affect what you can do?
It's a very good question that I had our lawyers look into.
Yeah, and that's what I'm trying to get.
So R, so R is GPL license, which means that if you, well, I'm not going to interpret the license, but basically it's contagious. The headers of R are, I believe, LGPL, which is less contagious. We don't use any of the headers. We don't use any of the R stuff directly. We use R.net. We interface with R. R.net had an LGPL license, which the guy changed to BSD license with some advice from our lawyers. So basically, because he's not, we believe that because he's not using, he's extracting information from the header files. LGPL is kind of slightly vague on if you use header files, whether that means the license is contagious or not. But it's typically, I think the spirit of it is if you are inlining functionality from header files, then you may need to apply the LGPL license. But if you're just using it as a header file, you get signature information on all the functions you need. So.
Okay, but your suggestion of including things into the source code repository,
Yeah.
I think that's when it gets a little fishy, because if you distribute R with your library, then the contagious aspect of GPL.
Well, if you're distributing it to, so it being in your source code repository internally in a company, if you're not distributing it externally, I think that's fine.
Yeah.
Not a lawyer, but I think that's fine. If you're distributing externally, sure, you wouldn't want to do that. Yeah. And certainly you want to include the licenses of all things, the closure of things you depend on, whatever you use. Anything else?
So it seems like it's really great as you're developing as a program or something like that. But is there, do you have any, I guess I'm imagining that eventually some of this starts to stabilize and productionize or something like that. How does, is there any story related to doing, like, at some point, they don't actually want to dynamically look up anything?
Right, so when you compile code that uses the R-type provider, what gets inserted into that compiled code does not do any dynamic reflection of it. Actually, that's not 100% true. It shouldn't do any dynamic reflection. It should use the information it's reflected out during compile time. It doesn't do that at the moment simply because it's slightly more complicated to implement than it didn't do it. So the idea is when you write a type provider, you you do the reflection, access the external resource, compile time, IDE, in the IDE, but in the code you generate, you output in your quotation, that should just contain code that is derived from that reflection information.
So it generates some sort of code that you can actually check in.
No, so when you use the type provider, when you compile, you expose some method, right? You expose that to the compiler as a quotation, which is a higher, lifted representation of the code. The compiler then injects that code into the binary that it compiles of the client application. So that client application will not necessarily be dependent on your type provider. Right? So it doesn't need to be dependent on your type provider. It can, in our case, it actually is, because we have some utility code in there. But yeah, that could be split out. So ideally, if you write type providers well, then there won't be any runtime dependency on the external resource for the purpose of reflection. Of course, it's got to be there to actually access it, because presumably what your code is going to do. You still need when you run, you still need an R installation, which in our case basically means you need RDLL, and you need, if you've got the DLLs, and you need the packages. That's basically it.
I think your question was, the next time you build it, you still need access to R. But I think you mentioned something about the type provider being able to save a schema or something. Is that?
Yeah. So I mean, this type provider doesn't save a schema as it stands. It could. So every time you build, you need to have access to an R installation. That R installation, well, an R installation is just some DLLs and packages, essentially. It's a very lightweight installation. It doesn't require any invasive action on the machine. So you can check a bunch of that stuff into your source code, your source repository, and then build against that. We don't actually do that yet, but we probably will.
I'm just wondering, so if I'm another developer, you've done all the development, but check out the code, same code. If I didn't have like a matching installation,
Yep, unless you have checked you committed the R DLL and packages you're using into source control, and you point to that when you're doing the compilation, that will make it a robust file. Because we're a small group, we don't care too much about that. But if you're a larger organization, you want to do something. And maybe it would make sense for the R provider to do schema caching, caching the signature information, and then you can kind of check in that schema file along with your code, and then use that instead of the R installation. That might be better. I mean, you can do it a number of ways, but yeah, I mean that's one way of doing it. You can put the schema file in alongside your source code, and then refer. Yeah, it's a parameter. It's a static parameter of the type provider. So it's like there's no mechanism built into F# managing schema files. It's the type provider has to do it. So.
What you use the code, the erase type?
Right. So the erase type. So in the code that gets generated. These things are just erase types. They're just objects. Yes.
Do you take patches? Like if other people wanted to work on it?
Yeah, of course, definitely. Yeah. Absolutely.
Does it work with real time?
Not with R, no. I don't think R is particularly something you want to use for real time. Oh, it certainly will, but it's not going to work for sort of low latency. It's good for kind of time series.
Have you found a mix of F# and R being sort of very useful utility?
Yeah. I mean, I think it's a very good combination. Certainly with the exploratory part. So, honestly, we haven't deployed any applications that actually use this. So we've used it for exploratory analysis. We have things we can run, see the results. We haven't built any applications to deploy them to users that will do this. It should work. Seems like it would, but we haven't done it.
Do you have any schemes to make it slightly more type safe in the future, or any sort of ideas about how you would take that next step?
Yes. One is that you could provide somehow some more precise type information separately from the R installation, particularly for common functions that you use all the time, so you want to have more precise types. So you could do that. That makes the the fact that you can, so at the moment it's object, so you can pass the symbolic expression, and that is already in R. Say something takes a double, or a vector of doubles. You know, you could say I can generate a function that instead of taking object takes double array, or double, seek the double. Right? But then you couldn't pass the symbolic expression instead, unless you did some really crazy stuff. Yeah, I don't know, you'd have to use overload. I don't know how you do that and still allow the function, the values to pass over.
So would it be possible potentially to sort of cut out the middleman? Because they're just like C-decal, probably DLLs that R is using, maybe? And
Yeah.
as sort of a long-term, like large-scale version of this might, for like compilation time, actually go around R.
So you mean actually access the packages underneath directly? Because we are calling R DLL, right? We're doing it via R.net, which is basically like a PE wrap around R DLL, right? So it's fairly direct. It's calling into the R engine, so there's a lot of stuff going on there. But the packages are, I would say, the code in the packages is usually 80-90% written in R, often 100%. Some packages have a lot of C code in them, but a lot of them, when they're particularly performance critical stuff, they have C code in them. But most of the packages you want to call are written in R, so you need to have the R interpreter available, which is inside RDLL. Anything else? Good. All right. So to the part.
Thank you so much.